ratios, 13-6. The objective of this lesson to find sides and angles of triangles using the sine, cosine, and tangent ratios. Let me give you a little bit of a background how mathematicians were able to come up with sine, cosine, and tangent ratios. Background: right angles are nice and neat with their side lengths obeying the Pythagorean theorem. We know that. Any two right triangles with the same non-right angles are similar. So in the technical sense, that their corresponding sides are also in proportion. For instance, the following two triangles, of course not drawn to scale, have all the same angles, so they are similar and corresponding pairs of their sides are in proportion. What is it saying? You have two right triangles, okay? And in any two right triangles, if their angles are congruent to each other, so if this angle is congruent to that angle, and this angle right here is congruent to this angle right here, they are similar right triangles. Okay, if they're similar right triangles, their corresponding sides are in proportion. That means 10 is in proportion with 5, 6 is in proportion with 3, 8 is in proportion with 2. How do we know this? If we look closely, the ratios of the corresponding sides, 10 over 5, 8 over 4, and 6 over 3 have a ratio of 2. Okay, so they are all in proportion. Look at also the ratio of the hypotenuse to the base. Remember, the hypotenuse is the longest side. So this is our hypotenuse. It is the longest side of the right triangle. The ratio of the hypotenuse to the base is 10 to 8 and 5 to 4, which gives us a ratio of 1.25. Look at also the ratio of the hypotenuse to the height, 10 to 6 and 5 to 3. Okay, will also have the same ratio of 1.666. And finally, look at the ratio of the height to the base, 6 over 8 and 3 over 4 will have a ratio of 0.75. So what does this tell us? Okay, around the 4th or 5th century, somebody very clever living in or around India, you don't need to know the name, but the name is around, I think, Bhaskar the first, Bhaskar the second. Notice that these consistency of the proportionalities of right triangles with the same size base angles, and started working on tables of ratios corresponding to those non-right angles. There will be one set of ratios for 1 degree angle, 18990 triangle, another set of ratios for 2 degree angle, 28890 triangle, and so forth. These ratios are called trigonometric ratios for the right triangle. Okay, what is it saying? It simply means this. If you have a certain right triangle, okay, a certain right triangle will always have, of course, okay, a right angle and two acute angles. And each right triangle will be unique in terms of their angle measures. Okay, if this angle measures 1, okay, and this angle measures 89 right here, okay, this particular right triangle will have a unique set of ratios, meaning the base hypotenuse height ratio, the hypotenuse a base ratio would be unique for that particular right triangle. This simply means that it doesn't matter if the triangle is big or small, for as long as the angles have the same measure, they will still have the same ratio. And this is what this is what they discovered during that time, 4th or 5th century AD. Okay, and that's more or less how they came up with trigonometric ratios. Okay, to continue on what they did, okay, if we consider this right triangle right here, given the right triangle with non-right angle designated as theta, let's say we name this angle as angle theta, we can label the hypotenuse always the side opposite the right angle. So if this is our right angle, okay, the opposite side of our right angle will always be our hypotenuse or our C. Okay, and label the other two sides with respect to theta. If this is theta, okay, we know that the opposite side of theta is that side, and the side next to theta, or the side adjacent to theta, is this side. Okay? So, given that we name this angle theta, that is the opposite side, and this is the adjacent side. Now, let's consider another scenario. Let's say we name this angle beta. Okay? If this is beta, the opposite side of beta will be this side, and the adjacent side will be that side. And obviously, since this is a right angle, this is always your hypotenuse. Okay? And we need to remember that the hypotenuse is always the longest side of our right triangle. Concept about trigonometric ratios. The word trigonometry means triangle measurement. The ratios of the measures of the sides of the right triangle are called trigonometric ratios. Three common trigonometric ratios are defined below. So when they say three common trigonometric ratios, these are the most commonly used ones, but there are six of them. Okay, so for our own purposes, 7th grade and 8th grade, we will learn the three trigonometric ratios. When you get to high school, you will learn the other three. So the three that we will learn today will be the sine, cosine, and tangent ratios. You will learn later on that there is the secant, cosecant, and cotangent ratios. But let's not concern ourselves with those first. And let's take a look of the three trigonometric ratios which we are going to learn today. Okay, so in words, if triangle ABC is a right triangle and A is an acute angle, remember what an acute angle is: an angle measuring less than 90 degrees. Okay, so sine of angle A is a measure of the opposite leg of angle A. Okay, it's the measure of the opposite leg of angle A over the measure of the hypotenuse. So if this is angle A right here, okay, so it's the opposite side over the hypotenuse. Cosine of angle A is the measure of the adjacent is measure of the leg adjacent to angle A, okay, and the measure of the hypotenuse. So if this is angle A, cosine of angle A would be the adjacent side, which is B, over the hypotenuse, which is C. And tangent of angle A will be the measure of the leg opposite angle A, okay, that side, over the measure of the adjacent side leg to angle A. So it's A over B. Okay. So in symbol, sine A is equal to A over C. Cosine A is B over C, and tangent A is A over B. Notice that angles, okay, the name of the triangle, the letters of the triangle are in capital letters, and the sides are in lowercase letters. Okay, the name of the angle is in capital, the name of the sides are in lowercase letters. So take note of that so you won't get confused. Okay, so what do we know? Sine, cosine, and tangent are abbreviated as SIN, COS, and tangent respectively. There's an easier way to remember these three ratios, and this is the SOHCAHTOA way. Again, SOHCAHTOA. What does that mean? Okay, if you take that is our sine ratio, which simply means it's the opposite over hypotenuse. So S is sine, O is opposite, H is the hypotenuse. Sine equals opposite over hypotenuse. If you take Ka, our cosine ratio, okay, it's a measure of the leg adjacent and the measure over the measure of a hypotenuse. So it's adjacent over hypotenuse. So cosine is C, A is adjacent, H is hypotenuse. And TOA is our tangent ratio, which is the measure leg opposite over the measure leg adjacent to angle A. So tangent is T, O is opposite, and A is adjacent. So best way to remember our trigonometric ratios is memorizing the phrase, not even a phrase, SOHCAHTOA. So stands for sine equals opposite over hypotenuse. Ka stands for cosine equals adjacent over hypotenuse. And TOA stands for tangent equals opposite over adjacent. Okay? Only on the measure of the angle. The size of the triangle does not affect the value of the ratio. We explained that during the background of trigonometric ratios. So let's look at this one. Find sine S, cosine S, and tangent S to the nearest thousandths place. Okay, and this is the angle we want right here. Sine S, cosine S, and tangent S. Okay, let's take a look. So means sine S means opposite over hypotenuse. Okay, opposite leg over hypotenuse of angle S. So if you have angle S, the opposite side of angle S, okay, is 12, and the hypotenuse is 13. So this trigonometric ratio in terms of sine is equal to 12 over 13, or about 0.923, rounded to the nearest thousandths place. Okay? Take a look at the cosine ratio. Cosine ratio is Ka, which means cosine, measure of the adjacent leg over measure of the hypotenuse. Adjacent leg is 5, hypotenuse is 13. So we have 5 over 13, or about 0.385. Okay? And finally, let's take a look at the tangent ratio, tangent S. Okay? We know that tangent is TOA, okay, which is opposite over adjacent. Okay, so measure of the leg opposite angle S to the measure of leg adjacent to angle S, okay, which is opposite 12 over adjacent, which is 5. So tangent S is 12 over 5, or 2.4. Okay, and that is the how you find, okay, your 3 trigonometric ratios using SOHCAHTOA. Okay. Example number 2, find each value to the nearest 10,000ths place. Okay. If we are asked to find sine 37 degrees, all we need to do is take out our scientific calculator, enter 337, click on or press on sine button in your calculator, end up with 0.601815023. Now let me just remind you though that different calculators act differently, so make sure you study how you find the sine value of your calculator. Some calculators you need to press sine first, the sine button, and then 37. For this calculator, most calculators will have you press 37 and then the sine button to be able to find the value. Okay, so round it to the nearest 10,000, it'll be 0.0 or 0.6018. Okay, to find cosine 56 degrees, in the same manner, press on 56 on your calculator, press on cosine button, and you find the value to the nearest 10,000. Cosine 56 degrees is approximately equal to 0.5592, and tangent 72. Okay, press on 7 and 2. Okay, press on the tangent button, end up with 3.077683.537 to the nearest thousands. It's 3.0777. Okay, so that's how you find the value to the nearest 10,000, okay, of those particular angles, and using sine, cosine, and tangent ratios. Let's consider the last example. The end of an exit ramp from an interstate highway is 22 feet higher than the highway. If the ramp is 300 or 630 feet long, what angle does it make with the highway? Okay. First, we need to take a look at what's really happening. We need to visualize what's happening. So you have the ramp that's 630 feet long. We want to find the angle of that ramp. okay, and it makes 22 feet, okay, higher. It is 22 feet higher than the highway. So we have this right angle, okay, and we want to find the angle of that ramp. Okay, so what do we know? We know for a fact that we want to find the angle x, okay, and what is given? What is given is the hypotenuse, which is 630 feet, and the opposite leg of angle A, which is 22 feet. So if this is angle A, 22 feet is the opposite leg, 630 is the hypotenuse. Then we need to ask ourselves okay, how are the opposite legs and hypotenuse related to each other in terms of our trigonometric ratios? We have opposite and hypotenuse. Opposite and hypotenuse will probably give us the SO ratio or sine ratio, which is SO. Okay, SO means opposite over hypotenuse. So now we have angle x, sine of angle x, because we're using the sine ratio in SOHCAHTOA, 22 over 630, okay, will be our ratio. Find the value of that. We'll get 2.001219, okay. How did we get that angle? Because we got 22. Using our calculator, divide by 630, okay. Press on the equal sign and then press on sine to the -1 button, okay. And then the ramp makes an angle of about 2 degrees with the road. Now, again, let me caution you, some calculators will let you press shift before you click on sine -1, and so on and so forth. Okay? Now that we're done with this lesson, make your summary and questions later that you might ask the following day. Thank you.